Hi friends. Hi friends. Previous video we talked about the mechanical clutch. Now in this video I am going to explain about the manually shifting a simple sliding mesh transmission, which are on the critical parts of the sliding mesh transmission, how they work. Friends, in the previous video we talked about the clutch, that is mechanical clutch, and prior to that we discussed about the necessity of the gearbox in a vehicle. Now this video will discuss about a simple sliding mesh gearbox. As discussed, the purpose of the gearbox is to change, that is increase or decrease the torque by varying the output shaft speed depending upon the driving conditions or road conditions. Keeping the engine speed, that is gearbox input speed, constant, the output speed of the gearbox varies to multiple ratios. Normally, all passenger cars are fitted with 6-speed gearbox, that is 5 forward speeds and 1 reverse speed. Change of speed ratio, that is input to output, occurs based on the engagement of the respective gears, that is 1, 2, 3, 4, 5 and reverse. Lower range gear have higher gear ratio and higher torque but with low output speed, whereas higher range gears, as the gear range increase, that is first to second, second to third, third to fourth, they will have the lower gear ratios by gradually increasing the output speed but decreasing the torque. Normally the reverse gear will have the higher gear ratio normally. If you consider some of the vehicles, commercial vehicles like jeeps or something, which have the 4 forward and 1 reverse gear, the gear ratios will be like this. If it is a first gear, it will be 3.91:1. The second gear 2.37:1. Third gear 1.48:1. Fourth gear is the direct gear, that is 1:1. And reverse will be having 5.31:1. If you precisely speak about the gearbox, the ratio is nothing but the speed or RPM of the input shaft divided by the RPM of the output shaft. We understand from the gearbox arrangement, this is the gearbox arrangement, that speed is inversely proportional to the torque. Means if the torque is increased, speed is reduced. If the speed is increased, the torque is reduced. The higher gear ratio will have the lower output speed with higher torque, and the lower gear ratios give the higher output speed with low torque. In the automobiles, we can see two types of transmissions. One is the latest, normally the latest vehicles, all the majority of the latest vehicles and the construction machines and the latest buses, they have the automatic transmissions. This is the automatic transmission, which is built with planetary gears or epicyclic gears. This is the typical planetary gear arrangement. This is called sun wheel. This is called planetary wheels. This is called the ring gear. The back side, the gray one, is called the planetary gears, planetary case. What is planetary gear, epicyclic gears? I will be going to explain in the coming videos in detail. Okay. And these gears, these drives are actuated through multiple disc clutches, which they have shown here. These are the gear sets. These are the multiple disc clutches operated through hydraulic pressure. And instead of the mechanical clutch, the automatic transmission will have the torque converter. We will be talking about the torque converter also in the coming videos. And the other type of gearbox or transmission is the manually shifting gearbox. This is the typical example of a constant mesh, synchro mesh, manually shifting gearbox. The gear wheels looks like this. These are all helical gears. This is the gearbox fitted in the majority of the present generation vehicles if it is a manual transmission. This is the gearbox. This is the input shaft, main shaft. This is the counter shaft, which we will be discussing in detail. And the gear wheels in the mechanical gearbox will be like this. The driver and driven gear, like this. This video will be focusing mainly on a simple manually shifting gearbox. Two types of gearboxes. Yes. This is the synchronous gearbox, as I explained, which is fitted in the current generation vehicles. And if we talk about some old type of gearboxes, we can see the sliding mesh gearbox. This is the sliding mesh gearbox. This used to be fitted in the olden type vehicles, and this gearbox also uses in some industrial applications. Sliding mesh gearbox means the gears on the main shaft will be slided to match the required gear ratios. I will be explaining about this. The sliding mesh gearbox will be having the spur teeth, means straight teeth. This is the spur teeth. Whereas the synchronous gearbox or constant mesh gearbox will be having the helical teeth. This is helical teeth. Spur gear and helical teeth gear. The helical teeth gear will be having a lot of advantages because the contact area will be more, noise will be less, load bearing capacity will be more. Whereas in the sliding mesh gearbox, this helical teeth arrangement is not possible, so the spur gears are fitted. This is the gearbox. This is the main shaft, the drive. You just see the typical simple sliding mesh gearbox diagram for easy understanding. The actually gearbox may be different from this diagram. This is the drive coming from the engine via the clutch. The drive is coming here. This is having the external splines. The gears are sliding here, and this is the counter shaft. This is the counter shaft, right? This is the additional idler wheel used during the reverse gear engagement. So engaging an idler wheel changes the direction of the output shaft. If you slide like this, this is coming, just let us see this diagram. This is one pair, this to this, it is engaging here, now it is neutral, then it is engaged here, now neutral, then third, then this is fourth, and again reverse. See again, this is first engagement, second engagement, this third, this is fourth. Don't get confused with the ratios or sizes of these gears. This is given only for the illustration purpose, right? This is the output shaft. Now let us see these diagrams. This is also a sliding mesh gearbox. Okay, this is the main shaft. This is the counter shaft. This output shaft also is fitted in the behind the main shaft. This arrangement. Drive is coming here to the small gear, and this is the counter shaft. Here the gear reduction. If you want to engage the first gear, it is engaged like this. Okay. Then again, this is direction, this is opposite. Again, the direction is changed. The original direction has come here. It is going to the differential. And you second gear. This is the second gear. Engaged. Now slide this back and again engage the third gear here. Then move this again here and engage the fourth gear. This one, like this. This is the additional gear wheel, additional idle wheel to get the reverse direction. This is the simple arrangement. The shifting of the gear wheels is done through the mechanical force by the driver. You see the animation, the first gear and second gear and again like this. First to see the first gear. The first gear, it's coming here, driving is coming, and this is the one. So small gear and bigger gear, highest gear ratio. Then little bit higher gear, little bit. The second medium, this is the first gear. With input speed is more, output speed is less, because the number of teeth are more in this. So here the maximum reduction, high torque, low speed output. This is slightly little bit reduction. This is medium range. This is the medium gear or second gear. When you directly couple this, this will be the top speed gear. If you couple this directly, it will be, this is the second gear, and this is the direct coupling is nothing but the top gear. This is the typical arrangement in the sliding mesh gearbox. The sliding mesh gearbox looks like this. This is the lever, this is a force which are used to shift the gears. The mission has to be, clutch has to be pressed and drive has to be disconnected here, and the required gear is to be shifted. This is actually very old type gearbox. This is having a lot of constraints, the sliding mesh gearbox. What are the constraints in the sliding mesh gearbox? It is an outdated design for automobiles. Even though it may be used in some industrial applications, but for automobiles it is an outdated design. It having the limited speeds, the olden transmissions. It is very noisy in operation because of the heavy gears and that also spur gears. And the load bearing capacity of the sliding mesh transmission is comparatively lesser than the synchro mesh gearbox. The reason being what I have shown in the previous slide about the spur gears versus helical gears. And the life of this gear wheel will be comparatively lesser to the synchro mesh, because in the synchro mesh gearbox the gears wheels are constantly meshed with each other and there will not be any sliding movement. That which I will be explaining in the next video. Because of that, the life of the gear wheels will be more here, and it needs little bit more fatigue, more energy compared to the shifting in the synchro mesh gearbox. These are the some constraints. Anyway, it is updated one. It's for your easy understanding of the gearbox function. I have presented this video.